Okay. So here's another example that'd be good to do. So that's the wrong button. So let's say we had this, okay? We have 1 over x squared plus 2x plus 1, okay? And let's say we want to find the domain. So again, the domain is all numbers x such that the denominator is not 0. So first, what we're going to do is determine when the denominator is 0. And that's what I'm doing here. These are the numbers, whatever the solutions to this, those are the numbers we're going to throw out. Now, so from here, what we get is we get 2 numbers. So here we want to factor. So what I'm going to do is factor this. You don't have to factor. You could use the quadratic formula, but I'm going to factor here. So in this case, for this kind of polynomial, right, we have x squared plus bx plus c. That's what we have here. To factor that, we want 2 numbers whose product is 1, but the sum is 2. Okay, well, how are we going to pull that off? Well, what 2 numbers do that? Well, what if they're both equal to 1? Right? 1 times 1 is 1, and 1 plus 1 is 2. So from here, we get this. Okay? And hence, what we get is this thing, x plus 1 squared. So we want to solve this here equal to 0. Now, if you have something times itself, right, equal to 0, well, that something itself has to be 0. That something has to be 0. In other words, we have x plus 1 times x plus 1. We want to know when this product is 0. So normally, you would set each factor equal to 0. Now, in this case, the factors are the same, so we just have x plus 1 equal to 0. Hence, we subtract 1 from each side. Right? We have x plus 1 equals 0. So we subtract 1 from each side. And it follows that x is negative 1. Right? So from here, we get that the domain is all numbers except negative 1. We have this factor equal to 0. And again, normally you would set this factor equal to 0, but these 2 factors are the same. So not only that, what we get is the domain is all numbers except negative 1. So the solution to this equation is x equals negative 1. So the domain is everything else except that. Okay, so that's one example. Here's another one. This one I'm doing a little bit different. We have x squared plus 4. I mean, you could try factoring this, but you're not going to be able to. Here, what you could do is actually the quadratic formula. Although, if you remember, I'm actually saving a little bit of work by just looking at the discriminant. You know, in 1.2, I did go over what the discriminant was. Section 1.2. It's basically b squared minus 4ac. So if we calculate that, right? Remember, a is 1 in this case. There's no x term, so b is 0, c is 4. From here, we get this. It follows that we get negative 16, which is negative. In other words, if you tried to solve this using the quadratic formula, this is what's under the square root sign. This would be negative, hence there'd be no solutions to this. I mean, I'm just saying here that, well, let's just calculate the discriminant. And we can see that the discriminant is negative. So we save a little bit of work and we can see, well, the discriminant's negative. This has no real solution. So that's all. In other words, since this has no solutions, we don't have to throw out any numbers. Every number is in the domain. So we have that. But you can also remember that if you do x squared plus a positive number, we saw earlier that that cannot be factored. We actually saw earlier that this cannot be factored, and it has no solutions. I think we might have seen that earlier. So the domain, again, is all real numbers. Are there any questions about this? I hope that wasn't confusing. I mean, I'm just really, in the long run, just using the quadratic formula. I'm just trying to save some work. So. All right. So here's another example. Again, it's just like before. We have the square root of something, right? 4x minus 3. So we want to know when 4x minus 3 is positive. And that's what I'm doing here. So we have 4x minus 3 greater than 0. So I'm just solving that inequality. It's really just like before.